Okay, class, today's lesson is on measuring segments and angles, and by the end of this lesson, you should be able to use properties of segments and angles to find their measures. So let's go ahead and get started, but first we need to define some terms. Okay, so although these are basic, it's important that we define these three definitions that are the basic building blocks of geometry. And these are considered undefined terms because these are meanings that are accepted or understood really without any formal definition. But let's go ahead and define them. So as you probably already know, a point is a location and has no size. Okay, so in a diagram you're going to be given a dot and it's going to be labeled with a letter. In this case it would be P. And then in geometry the notation for a point will just be an italicized letter. Okay, and then the next one is a line, and a line is defined as an infinite number of points on a straight path that extends in two opposite directions with no end and has no thickness. So this would be a line. Okay, it extends in two opposite directions with no end, and that's what these arrows mean, that they go on forever and forever in that direction, and a line has no thickness. Okay, and then the notation in geometry would be as follows. It would say line L, for example, since this is line L, or it's going to have AB with a line symbol above it. Okay, and then the last undefined term is a plane. Okay, so this would be a diagram of a plane, and there are infinite number of points in here. And it's defined, a plane is defined as an infinite number of points and slides on a flat surface that extends without end and has no thickness. Okay, correction. I made a slight mistake in the wording, and this should be lines. So a plane is an infinite number of points and lines on a flat surface that extends without end and has no thickness. Okay, so infinite number of points, and you could also have infinite number of lines in here along this plane, and it has no thickness. And then the notation for a plane would be as follows. We could say plane M or plane XYZ, identifying 3 points on a plane. Okay, so those are the undefined terms. So we're going to use this as the basis for defined terms. So in geometry, new terms are defined using previously defined or known terms. So we've already defined a point, line, and a plane, and now we're going to use that to define 4 new terms. Okay, so the first one is called a segment, and a segment looks like this. Okay, it's got 2 endpoints and an infinite number of points in between them. Okay, and then the notation would be as follows. It would be AB with a line above it with no arrows on top of it. Okay, and then the second term, second defined term here is a ray, and that is part of a line that starts with an endpoint, and then on the other end is an arrow that extends in that direction to infinity. Okay, and the notation in geometry would be, for example, MN, okay, with a line above it and then an arrow on one side. That would be a notation for a ray. Okay, and then the next term is the opposite rays, and these are rays with the same endpoint, okay, that lie on the same line. So for example, we have a ray TS, okay, that extends from T through S, and it continues on to the left to infinity. That's one ray. And then we have another ray with the same endpoint, T, except this one is TU, and this ray extends to the right into infinity. And so even though this looks like a line, okay, it is actually made up of 2 opposite rays. And then the notation for the first ray is TS, okay? TS with a line and an arrow. Notice that we didn't say ST. We always start on the endpoint and then go in the direction where the arrow is going. So in this case, it would be TS. And then the other ray, which is TU, is noted as TU with a line and the arrow above it. Okay, and then this leads us to the fourth and final term, and that is an angle. Okay, and an angle is formed by two rays. So we have ray QR and QP. Obvious, and you'll notice that it has the same endpoint Q. Each ray is a side of this angle. Okay, and the common endpoint Q is also called the vertex of the angle. And then the notation for this angle could be as follows. We could call this angle Q, angle PQR, so it would be PQR. We could also write this as angle RQP. Either way is fine. Or angle 2, as it's labeled here. Okay? So let's see how this is used in an example. Let's suppose that we have points F, G, and H on a line, and they are collinear. Okay, and the term collinear means that these points all lie on the same line. Okay, if segment GH right here is equal to 16, what is the segment FH? Okay, so how do we do this? We're going to start with what's given, and it's telling us that GH is equal to 16. Okay, so we're going to write GH is equal to 16. Okay. We also know that GH is represented by 2x plus 2. So we're going to replace GH with 2x plus 2. So we're going to write 2x plus 2 is equal to 16. Okay, so now we can solve for x. We're going to subtract 2 from both sides, okay, and we're going to get 2x is equal to 14. Then we're going to isolate this x by dividing both sides by 2, okay, and we get x is equal to 7. Okay, so we're going to just label this step 1. Okay, and then step 2, we're going to do as follows. We're going to define f of h. Okay, so this entire segment, f of h, is really the sum of fg and gh. Okay, so we're going to go ahead and write that. F of h is equal to fg plus gh. Okay, so now we're going to substitute fg for 3x, or with 3x minus 1. Okay, so we're going to go ahead and write that down. 3x minus 1. And that is our FH, or part of FH. And then the other component is GH, okay, GH, which is defined by this expression, 2x plus 2. So we're going to go ahead and write that in, 2x plus 2. Okay, so now we're going to simplify what we've put together. 3x and 2x gives us 5x. And negative 1 over here plus 2 is 1. Okay, so our final equation is fh is equal to 5x plus 1. Okay, now in step 1 we solved for x, or we determined what x is, and that's 7. So we're going to plug that in for x. Okay, so now we get f of 8, or I'm sorry, fh is equal to 5 times 7 plus 1, and we find that FH, this segment, is 36. Okay, so let's go ahead and move on to a different example, and this time we're going to be solving for angles. Okay, so we're given this diagram, and we need to solve for angle X, which is right here, in the spot right here, and angle Y, okay? We're also given that this entire angle is 74, and from this ray to this ray, this angle right here, is 57. And lastly, we're told that this angle right in here is 22 degrees, okay? So how do we solve this? Well, to solve for X, okay, for this angle right here, we know that X, this angle X plus 22, this angle right here, is equal to this entire angle. Okay, so let's go ahead and write that out. X plus 22 is equal to 57. Okay? And then to solve for X, we're going to subtract 22 from both sides, and we find that X is equal to 35. Okay, so angle X is 35 degrees. And then to find angle Y, we see that angle Y, this angle, plus this entire angle gives us this entire angle. Okay, so let's go ahead and write that down as an equation. Angle Y plus 57 degrees is equal to 74. Okay, and then to solve for Y, if we subtract 57 from both sides, we get Y is equal to 17 degrees. Okay, well, I hope that made sense to you. If you had any questions or if anything didn't quite make sense, please go back to the beginning of this video and listen to it again. Thank you.